inverses, and we're going to talk about the reciprocals. And we're going to talk about tangent and its reciprocal. We're first doing cosecant. Remember, cosecant is the reciprocal of our sine function. All right, if you remember the inverse of our sine function, we could use quadrant 1 and 4. So hopefully we're just using these two quadrants, and then I just have to remember what sine is, and then I know what cosecant is. So let's go ahead and draw cosecant. Well, cosecant has asymptotes wherever sine is 0. And if we could picture the sine graph, it starts at 0, goes up, it's 0, goes down, it's at 0. So I have a vertical asymptote here. I have a vertical asymptote at pi. I have a vertical asymptote at 2 pi. All right, our drawing of that will be, well, it goes up first, so our first, between 0 and pi, it goes up. Between pi and 2 pi, it starts at 1, and it goes down in both directions. All right, I'm also going to graph the negative version as well. So way over here at negative pi over 2, that one will also go down following that pattern. Now I need this one. I need this one because I need to create a function that passes the vertical line test. Well, if I just take this and box it in, that does not pass our horizontal line test. It hits twice. So we're going to take half of both of these. And what I mean by that is I'm going to draw a box around, that's a little tick. We're just going to go straight down here, take half of that one, come over here and take half of that one. That's the biggest slice I can take. And if we look at it, that's from negative pi over 2 to pi over 2. Well, pi over 2 is, in our unit circle, is way at the top. Negative pi over 2 is way at the bottom. So it's telling me I can use all of this, but I can't use any of that, just like the sine function, or the sine inverse. So our sine inverse and our cosecant inverse both share the same domain. It's the right half of our unit circle. In other words, I'm going to fill in that. We can use quadrant 1 and quadrant 4. All right, let's go ahead and graph the inverse just to see what it looks like. Well, I'm going to use the points that I put on here. So this point here is pi over 2, comma 1. The other point I'm going to use is the one that's negative pi over 2, comma negative 1. All right, pi over 2, 1. To do the inverse, we swap our x's and y values. So instead of pi over 2, 1, I'm going to plot 1 pi over 2. And now we have to think back. In order to know which way this goes, we have to think back about graphing inverses. Well, when I graph an inverse is reflected across y equals x. Do you remember that dashed line that we draw? And then we try to picture what happens when you flip it over. Well, that's what's going to happen here. So this is going to get flipped over that axis and look something like that. My thing doesn't, but it looks like that. So this one is going to go down like that. This one, when it gets flipped over our y-axis, is just going to go the other. Ooh, I didn't even plot the point yet. Let's plot the point first. So we're going to do negative 1 pi, negative pi over 2. All right, this guy getting flipped over is going to do something like that. So it's going to go, they're both going to go towards the x-axis. And what could have told us that is the fact that if I have a vertical asymptote along the y-axis, the reciprocal of that is going to be a horizontal asymptote along the x-axis. So all of our verticals are going to turn to horizontal asymptotes. And that would have told me, as soon as I drew this, that these are getting sucked up close to that asymptote. All right, so that's our graph of our cosecant function. And we're we're relegated to quadrants 1 and 4, and surprisingly it's really important that it shares the same quadrants as sine inverse. Because what that's going to allow us to do is come up with this really important rule. Alright, as a little note, that cosecant pi over 6 equals 1/2 and sine pi over 6 equals 2. So what that leads us to, and the fact that they share the same quadrants, is cosecant inverse of x can be replaced or is equal to sine inverse of 1 over x, or just the reciprocal of x. Now this is super, super important that you know this, because you don't want to spend your whole time looking at where is cosecant equal to some number, because then you'd be flipping signs. You're going to have to be reducing fractions if you have square roots on bottoms. It's just easier to look at our sine function. All right, do the reciprocal first and look at the sine version of it. So an example of this, if I have cosecant inverse of square root of 2, I could just rewrite it as sine inverse of 1 over square root of 2. Well, our unit circle doesn't have square root of 2's or anything on the bottom, so we're going to multiply the top and bottom by square root of 2. And that's just going to equal sine inverse of square root of 2 over 2. Well, square root of 2 over 2 is in our first quadrant. It's that second tick mark. And so we are going to have pi over 4. Okay, arc cosine of 1. Well, that's just going to be arc sine of 1 over 1. Well, 1 over 1 is just 1, so we're really just looking for arc sine of 1. Where's sine 1? Well, sine 1 is 1 at the very top. That's that 0.01. So that's going to be pi over 2. Any questions on any of those numbers or how I did any of that? So it's just easiest if you just remember this. This fact will help you. Okay, inverse of secant. The first thing I'm going to do is I'm going to draw my secant function. Remember that secant is going to be undefined wherever cosine is 0. Well, if we picture our cosine function, it starts up here, so it's 0 here, it's 0 here, 0 here. And let's go ahead and fill in those vertical asymptotes. Bless you. So it's 0 here. It's 0 here. In other words, it's 0 at the halves. Cosine is 0 at the halves, which means that the vertical asymptotes are at the halves also. All right, just like sine, put a point in the middle. This one goes up and up. At pi, right in the middle, it goes down. It goes down. And if you wanted to, you could graph a whole another half of the cycle. We don't need all of that. We just need those first two. Because just like we did with cosecant, we're going to kind of cut each of these in half. So I'm going to say, I'm going to take half of u. I'm going to take half of u. And that's going to be 0 to pi. My domain is from 0 to pi and nothing else. If you remember the cosine inverse, that was also quadrants 1 and 2. So cosine inverse and secant inverse share the exact same thing, which is nice because they're reciprocals of each other. So, like we said before, this is going to be quadrants 1 and 2. Now the graph of this, let's grab some points. We can grab the point 0, 1. And I can also grab the point pi negative 1. The reciprocal is x and y flipped, so rather than 0, 1, I'm going to have 1, 0. And instead of pi negative 1, I'm going to go negative 1 pi. Okay, before I draw any lines or anything like that, let's picture where our horizontal asymptote is going to be. Well, if I have a vertical asymptote at pi over 2, that means on the reciprocal, I'm going to have a horizontal asymptote at pi over 2 because our inputs and outputs change places. So we are going to have horizontal asymptote there, which is going to kind of lead us to the fact that this is going to go like this, and this one's going to go in that direction. And if you wanted to, you could do your hand gesture and try to break. Well, it looks like that. And that's what it looks like. Okay, so that is secant function. That's the graph of it. Just like sine inverse and cosecant inverse, we have a rule for this one. Secant inverse x is the exact same thing as cosine inverse 1 over x. So this one is also a really nice one. As long as you remember that, these two are really nice. They don't have any additional rules. We just got to do 1 over x. So secant inverse of negative 2 is the same thing as saying cosine inverse of 1 over negative 2. So I'm looking for negative 1/2. So if we look for negative 1/2, and I have to stay in quadrant 1 or 2, it's going to be right here, which is 2 pi over 3. So that's going to equal 2 pi over 3. Arc secant of 2 is going to be the same thing as arc cosine of 1/2, which is going to equal, if we picture our unit circle, that's going to be the third tick. Because sine is 1/2 on the first tick, which means that cosine on the third tick is going to be 1/2. Remember, it goes pi over 6, pi over 4, pi over 3. So we're going to be pi over 3. And that's all we need to know about secant. All right, inverse of tangent. That one's fine. That one's fine. We just got to know how to draw tangent function. Well, a tangent function, remember that tangent is sine over cosine. So our tangent function has vertical asymptotes wherever cosine is 0. And if we could picture our cosine graph goes like this. Right? So it starts at here. So my first 0 would be here, there. It is also on the halves. So our cosine is 0 on the halves, so that means that my tangent function is going to have vertical asymptotes on the halves as well. Man, that's an easy way to graph, just remembering where its cosine is 0. Oh, but you guys, it's pretty easy. Then I can make my marks in the middle. And now all I have to remember is that tangent is always increasing. Tangent is always increasing. Cotangent is always decreasing. So it tells me which way to draw my graph. So if it's always increasing, this is going to go up. So it's going to look like that, where they're always going uphill. Because remember, Pierre the ant can only walk in one direction from left to right. That's why these are always increasing. Well, the good thing about tangent is I don't have to cut anything in half. I really don't have to cut anything at all. I just have to say, I just want one of these guys. I'm just going to take this guy and just forget about the rest. It passes my horizontal line test. So I'm just going to take one of these guys. Nothing has to get cut. Well, that's from pi over 2 to negative pi over 2. Pi over 2 is up here. Negative pi over 2 is over here. So we're talking about quadrant 1 and 4. So this goes along with sine inverse and our cosecant inverse. So that means I'm stuck in quadrant 1 and 4. And the graph of this isn't so bad to do. We just have to remember that if I have a vertical asymptote somewhere, they turn into horizontal ones on its inverse. So if I have a vertical asymptote at negative pi over 2, I have a horizontal one at negative pi over 2. So let's go ahead and draw that guy in there. We have one at pi over 2, so it means I have one at pi over 2. That's horizontal over here. Either you can picture in your head, or you can just kind of, this is going to flip like this, right? So we're going to have, our top half is going to look like this. Our bottom half is going to go the opposite direction. So our tan inverse looks like that. And someone was gracious enough to give you a unit circle with all your tangent functions on it. Might make it easier to memorize them, because you should be memorizing them. Well, the tan inverse of square root of 3, if you memorized it, it goes square root of 3 over 3, 1, square root of 3. So it would be our third tick, which is pi over 3. This is right at pi over 3. All right, our arctangent of 1. 1 is always in the middle. Tangent's positive in quadrant 1. It's negative in quadrant 4, so I'm only worried about quadrant 1. 1 is in the middle of quadrant 1, so that must be pi over, what's my middle pi value? 4. Yeah, so it must be pi over 4. And if you don't believe me, let's go ahead and look at the unit circle really quick. So I did square root of 3, and I did, so square root of 3, yep, it's that third one. That was pi over 3, that's what I said it was. 1 is related to pi over 4. So the arctangent of 1 is pi over 4. I got those both correct. Any questions about how I got anything there? Please feel free to ask. Don't wait till 2 Tuesdays from and say, I never really got inverses. I always hate that. I hate that when, like, the day before the test, someone's like, I never really got them. Well, ask questions when I'm teaching them, or ask them the next day, all right? So make sure you ask questions if you're not understanding something. All right, this is the tougher of all of them. And it's just down here, and we'll get to down here in a second. But it's this part right here, and we'll talk about why it even exists like that. Don't be so mad at it. It's okay. Okay, so we're doing inverse of cotangent functions. Well, the first thing I need to do is graph a cotangent function. And cotangent, so if tangent is sine over cosine, cotangent is cosine over sine. So I'm looking at where sine equals 0. Those are going to be my vertical asymptotes. Well, sine, if we picture a sine graph, sine is 0 here, it's 0 here, and it's 0 here, so it's on the pi's. So for cotangent, our vertical asymptotes are on the pi's and the 0. And then we could put a dot in the middle of each of these. And remember, tangent's always increasing. So that means cotangent is always decreasing. So it's going to go in that direction. All right, so Pierre is always going downhill. Just like tangent, I don't need to split anything up. All I'm going to do is I'm going to take one of those suckers, and it'll be the first one. And that is from 0 to pi. And 0 is here, pi is here. We go around, and we got to cross out that. All right, that means I'm stuck in quadrant 1 and 2. graph of cotangent. Same thing as with tangent. I'm going to do my asymptotes first. Well, if I have an asymptote at 0, that's vertical. I'm going to have a horizontal asymptote at 0 for my inverse. So we got one here. And since I have a vertical asymptote at pi, I'm going to have a horizontal one at pi on my inverse. All right, and our graph is going to start right in the middle, and for cotangent, it's going to go down first and then up left. And I can't really do it, but the inverse would be like that. Kind of see it. My hand doesn't quite bend all the way. Okay, before I get to these crazy rules, we're just going to try one. We're just going to try one. All right, so we're going to do cotangent of -1. And we're going to assume it plays by the exact same rules as all of them play by. So I would first put it as tangent inverse of the reciprocal, which would be negative square root of 3. So the inverse, do we get how I just did the reciprocal here? It's 1 over square root of 3, it just turns into square root of 3. Are we all okay with that? Okay, if I want to go find this, tangent inverse of -3, I'd look at my unit circle. And I'd say, well, tangent inverse needs to be over here. So if I have negative square root of 3, hey, that's 5 pi over 3. Okay, do we all agree it's 5 pi over 3? Do we see the -3 down here goes to 5 pi over 3? Is that okay that I'm in this quadrant, though?
Yes. No.
It is not okay I'm in this quadrant, because cotangent inverse does not exist down here. Yeah.
So is it 2 pi over 3?
Say that again?
Is it 2 pi over 3?
It is going to be 2 pi over 3. Because what we need to do is we need to take this angle and we need to put it up here. It'll be the exact same angle. We're just going to put it up here. So that means we're going to take 5 pi over 3 and shift it up. That's where that rule comes in. Oh, did it shut me out? Yeah, it kicked me out. Hold on one second. So that's where it came up with the rule that if it's negative, if your value is negative, so this one here, we have to add a pi onto it. So it is actually going to be tangent inverse plus pi. So this has two possible answers that I would accept. The first one is you took tan negative, and we said that tan inverse of square root of 3 is 5 pi over 3. So you could do 5 pi over 3. You could say this equals 5 pi over 3 plus pi, but instead of writing pi, I'm going to write 3 pi over 3, just so I have the common denominator, which would equal 8 pi over 3. This is one of the rare cases I would accept this one, even though it's not, this is obviously past one rotation, right? Because this is bigger than 2 pi. So normally I wouldn't accept, but for this, I'm going to let you do that, just so you're not spending a whole bunch of time checking to see if you went that far. The other answer I would accept is if you would have did just like what Brian did, and he saw that, hey, 5 pi over 3, if I added pi to it, or subtracted pi, is actually 2 pi over 3. I would accept both of those answers. They're coterminal to each other. So we could do 8 pi over 3 or 2 pi over 3. I would accept either one of those answers, as long as you realize that you had to shift it up to that quadrant. That's what I really care about, is that you realize that if I have a negative number, I need to add pi to it. The other caveat is, if you have a cotangent inverse of pi over of 0, the answer is pi over 2. Automatically it's pi over 2. So if you have a 0 in for cotangent inverse, your answer is pi over 2. All right, my next one is arc cotangent of square root of 3. This is positive. Well, I was going to note that this 1/2 falls into that x is less than 0 realm. This one falls into the x is greater than 0, so I can treat it just like normal. That tan inverse of square root of 3. And why it works is because tan inverse is in a quadrant that's allowed by our cotangent inverse. And it was square root of 3, so it's going to be pi over 3. So this is going to be pi over 3, and we are done with inverses. The last thing we need to do is using our calculator to solve information. All right. So please let yourself know that this is important too. This right here is pretty important, especially because I can almost guarantee that if I put a positive cotangent one on, I'm going to put a negative one as well. All right, because the positive one's easy because it usually follows that, oh yeah, it'd be tan inverse of 1 over x. It's the negative one that's more interesting that you have to switch its quadrant. Right, Willie? So you got that test question ready? Probably, because I just told you 2 test questions. Okay. All right, the last thing we need to do is we need our calculator. This time we're going to put it in radian modes. So we're doing radian mode this time. I will, on the test, specifically tell you if you need to use a calculator, what mode it needs to be in. Either I'll put radian mode or I'll just put in radians. So I need to do the arc cotangent of 2.4. Well, if it's cotangent, I just got to decide is it positive or is it negative. This one's positive, so I don't have to add that pi to it. So in our calculator, we just need to do our arc tangent of 1 over 2.4. And I'm going to let you guys practice this. I'm just going to put the answers up. So this one I got 0.39 on. Yeah?
So you couldn't do the inverse of tangent, like tangent to the negative first.
That's the same exact thing. Arctangent is the same button as tangent negative 1 to the 1 over 2.4. These are both the exact same. You both come up with, because arctangent is just another way to write this. And the reason why they did that, and this is more speculation than anything else. Oh, thank you for notifying now. Yeah, I did it wrong and no one noticed. Oh, I didn't notice. I mean, I did it on purpose to see if anyone noticed. We should have said that was 1 over square root of 3. We absolutely should have had 1 over square root of 3. Which we would note isn't on my unit circle, that I would have to multiply the bottom and top by by square root of 3, which would give me square root of 3 over 3, and that would actually equal pi over 6, because that would be our first tick on our unit circle. There, that should be a lot better, right? Okay. And going back to this, we should have came up with 0.39. For cosecant, cosecant goes with sine, so we're going to go sine inverse of 1 over 4. Well, sine inverse of 1 over 4, if you plug in your calculator, should come out to 0.25. And I'm just going to run through these. Well, cotangent inverse of 0 goes back to our rule. That cotangent inverse of 0 is just pi over 2. And that came from the rule. And find the cotangent inverse of 1.3. Well, that's going to be tan inverse of 1 over 1.3. And since it's positive, we don't have to add the pi to it. So that's just going to equal 0.66.